Alright, this is a short lesson on taking what we call nth roots, and nth roots just mean any root. Okay, so the index could be anything. Could be a 2, like in the first case. Notice we don't show the 2. Remember, that's called the index. The index could be a 3, could be a 4. Okay. It's very important to recognize what your index is, because these 3 problems are asking 3 different questions. This one, the square root problem, is asking what times what gives you 16. It's only asking for 2 factors that are the same. In this case, 4 times 4. Remember, we like to think of that as a 4 squared. And then the index and the exponent cancel each other out. Okay, 16, but I want the cube root of it, so it's asking what times what times what. So if I start factoring 16 as 8 times 2, I might recognize 8 as a perfect cube at that point, but I'm just going to factor it all the way down so you can see it. And see, hey, it's got 3 2's multiplied together inside of it. Or again, think of it as a 2 cubed times 2. There our index matches our exponent, so it's a 2. We're left with the cube root of a 2. It's important to leave it still cubed root. And finally, 16 is asking 4th root of 16, so I'm looking for 4 things multiplied together this time. Okay, in this case, 16 is made up of 4 2's, so the answer is just 2. So you can see all these questions, square root of 16, cube root of 16, and 4th root of 16, very similar, but their indexes are different, and we get different answers for each one. So let's look at some of the homework problems so you can see how to do these things. Okay, the first problem, this is number 273. It's asking what's the 4th root of negative 16, and right away some alarm bells go off, because I've got to multiply 4 things together and get a negative answer. Okay, we just saw in the previous problem that 16 is made up of a bunch of 2's. Let's see if I could multiply 4 2's that are negative together. Now, 2 times 2 times 2 times 2 is 16, but every pair of negatives I multiply give me a positive. And I've got 2 pairs, so it's positive times positive. There's no way I can multiply 4 2's together and get negative 16. This thing would have an imaginary solution, in fact, and so we're just going to put no real solution to it, or it's not real. Okay, and in fact, when this thing is even, you cannot do the root of a negative. So even indexes have to have positive radicands, otherwise they are not possible. Let's look at 274. You'll see a difference in this one. This one's an odd index of a negative number, and that's okay. In fact, whenever you have the odd index of a negative or an odd root of a negative number, negatives can always be written as 3 negative 1's or 5 negative 1's or 7 negative 1's multiplied together. And so right away I like to take out that negative 1. And now I just have to worry about what's the 5th root of 32. And if you know that 1 is just 2, if not, you'd factor it and you'd find out it's made up of 5 2's. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And the question is, what's multiplied together 5 times? The answer is 2. And when it comes out, it multiplies by whatever I have out there. So negative 2 is my solution. Let's look at 175, or 275, sorry. 4th root, 16x to the 20th. Doing 4th roots. And if you know your factors or your powers, I know that 2 to the 4th is 16, and x to the 5th raised to the 4th power is x to the 20th. And I've written it that way so my index and my exponents match. And so what's multiplied together 4 times? 2 is. What's multiplied together 4 times? X to the 5th is. Now we have to be a little bit careful here, because x to the 20th is guaranteed to be a positive number. X to the 5th is not, so we're going to force it to be positive by putting it in absolute values. I'm going to jump ahead to a tough one. 7x cubed y to the fourth z to the fifth fourth root of 81 x squared y4 z6. Let's just forget about the stuff in the outside. We're just going to multiply that by whatever we bring out. Let's look at the stuff on the inside of the radical. 81 is 3 to the fourth power. 3 times 3 is 9, times 3 is 27, times 3 is 81. That's 4 of them. X squared is x squared. That didn't have 4 of them. Y to the fourth is already 2 to the fourth power. And z to the sixth I'm going to write as a z to the fourth times a z squared. It's still equal to z to the sixth, but now I've got a z with an exponent of 4, a y with an exponent of 4, and a 3 with an exponent of 4. So on the outside I still have this 7x cubed, y4, z5, and out joining it with multiplication is a 3, a y, and a z, and stuck inside is an x squared and a z squared. Let's check to see if we need absolute values on anything we brought out. 3 to the fourth is guaranteed to be positive, and we brought it out as just a 3, so it's positive already. Y to the fourth is guaranteed to be positive, but the y could go either way, so we should stick it in absolute values. Z to the fourth is going to be positive, so when I fourth root it, I better get a positive answer as well. So my best solution for this guy would be the 3 times 7, 21, an x cubed y to the fourth z to the fifth times yz in absolute values. And I can't, let's see here, I actually could do a little more simplifying. Y to the fourth is guaranteed to be positive, so I could take it times this y and get y to the fifth, but that'd have to still be in absolute values. Z to the sixth, I don't know if z to the fifth is positive or negative, so I should just leave it the way I have it written, with just that yz in absolute values. Okay, that's a pretty tough problem. Do one more. Oops. Let's do fifth root of 2y minus 1 to the 10th power. This is number 286. I'm going to think of that as the fifth root of 2y minus 1 squared to the fifth power. And I do that so that my index and my exponent match, and so my answer is 2y minus 1 squared. And that would be fine. We don't need to expand that or multiply it out. And that's how you solve nth root or simplify nth root radicals.